We are still on Pythagoras Theorem and we are looking at the application of it. Now that we understand the concept of Pythagoras Theorem, how then do we apply it in solving questions involving word problems? I know most students don't like application questions involving word problems, but I bet you application questions on Pythagoras Theorem are very simple and easy. You will love it. So let's go through it. So we have the first example on the board. Now, whenever you have an application question on Pythagoras Theorem, make sure you read the question 2 or 3 times to understand the question and then you digest it before you start solving it. So the first example, let's read it. Make sure you read it with me. A ladder leans against a vertical wall of height 10 meters. The distance between the foot of the ladder and the wall is 20 meters. Find the length of the ladder. Now we have a ladder, and I believe you all know a ladder, you have seen it before. A ladder is an equipment that is used for climbing up or down of something. It is normally in this very form. I believe you have seen this kind of equipment before. In tree, we call it afidie. Yes, that is what a ladder. So this ladder leans against a vertical wall of height 10 meters. So before we start solving it, let's sketch the diagram. We always sketch the diagram involving a Pythagoras theorem before we start solving it. Okay, so let's sketch the diagram. So we have a ladder leans against a vertical wall of height 10 meters. So it means that the vertical wall has a height of what? 10 meters. So let's draw the vertical wall. So this is the vertical wall, has a height of what? 10 meters. So we have 10 meters. But a ladder leans against this vertical wall. So let's draw the ladder. Wall. The distance between the foot of the ladder, this is the foot of the ladder, and the wall is what? 20 meters. So the distance between this and that is 20 meters. So let's draw it here. You are to find the length of the ladder. So this is the length of the ladder. Let's call it x. Now the vertical wall, which is this, makes a right angle with this very horizontal line. So we have a right angle here. Now you can see that we are having a right angle triangle, and therefore we can apply the Pythagoras theorem to find the length of the ladder. Are you getting the concept? So we know that the Pythagoras theorem, it says that the length of the hypotenuse, the square of the hypotenuse, so we are going to get s squared is equal to the sum of squares of the other two sides. So we have 10 squared plus 20 squared. So we are going to get s squared is equal to 10 squared is what? 100. And then 20 squared is 400. Now we have s squared is equal to 100 plus 400, we have 500. We are looking for x, not s squared. So we take the square root on both sides so that this and that will go. We are left with s is equal to plus or minus root of 500. Now root of 500 is equal to, I think, 10 root 5 or 22.3. Now, so we can say that our s is equal to negative 22.3 or s is equal to 22.3. Since we don't have negative length or negative magnitude, our s will be equal to 22.3. So at the end, we can say that the length of the ladder is, so the length of the ladder is 22.3. Very, very simple. Let's take the next example. So this is our second example. It reads, a ladder which is 17 meters is placed against a vertical wall. If the distance separating the foot of the ladder and the wall is 8 meters, what is the height of the wall? So with this one, we are going to find the height of the wall. So a ladder which is 17 meters. So with this one, the ladder is what? 17 meters. 17 meters is placed against a vertical wall. If the distance separating the foot of the ladder and the wall is what? 8 meters. Therefore, the distance of this and that is 8 meters. What is the height of the wall? So this is what we are going to look for, the height of the wall. So you can see that we have a right angle triangle, and therefore we can apply the Pythagoras theorem. Good, so let's solve it. So we know that this is our hypotenuse. So we have our hypotenuse squared. So we have 17 squared is equal to s squared plus 8 squared. Good. So what we are going to do is we are going to transpose this a squared to this very side because we are looking for x. So we are going to get 17 squared minus 8 squared is equal to s squared. Now 17 squared will give us 289, and then 8 squared will give us 64. We have s squared. So 289 minus 64, we are getting 225, which is equal to s squared. Now we are looking for s, not s squared. So we take the square root on both sides so that this and that will go. So we can say that our x is equal to plus or minus root of 225 is 15. So we have s is equal to 15 or x is equal to minus 15. But since we don't have negative length, we are going to pick our x is equal to 15 meters. So the height of the wall is 15 meters. The height of the wall is 15 meters. Very, very simple. You see how simple it is? Good. Let's take another example. So this is our third example. I want you to try your hands on this, and I'll write another example on this very side. So try your hands on that. So I hope you were able to solve it. What did you get? Let's solve it together to see if you are on the right path. So we have a ladder 16 feet tall leans against a vertical wall with a base 4 feet from the wall. How far off the floor is the top of the ladder? How far off the floor is the top of the ladder? So we have our ladder, we have our wall here. We have our wall here. So this is the wall. Then we have a ladder. So a ladder 16 feet. So the ladder is 16 feet. Leans against a vertical wall with a base of 4 feet from the wall. So the base is 4 feet from the wall. So the base of the ladder is 4 feet away from the wall. How far off the floor? So the floor is the top of the ladder. So we are looking for this very side. Good. So we are going to apply the Pythagoras theorem to find the length of the wall. So we are going to get 16 squared is equal to s squared plus 4. 4 squared. Good. So we know that 16 squared will give us 256, and then x squared plus 4 squared will give us 16. So we are going to bring this 16 to this very side. So we are going to get x squared is equal to 256 minus 16. So 256 minus 16, we are going to get our s squared is equal to 240. So we take the root sign on both sides. So this and that will go. We have our x is equal to, so root of 240 will give us 15.49 feet. So the length of the wall is 15.9 feet. Very good. And I hope this is the answer that you had. Now we have another example on the board. It reads a rectangle of height 8 centimeters and breadth of 6 centimeters. How long is its diagonal? So we are going to find the length of the diagonal. So let's start. A rectangle. So we are going to draw a rectangle of 8 centimeters and a breadth of 6 centimeters. So we have and a breadth 6 centimeters. Now, how long is it diagonal? So the diagonal can be this or that. So let's choose this. Okay, let's choose this very side. If you choose this side, the same thing. Okay, so let's choose this side. You know that this corner of the rectangle is at right angle. Good. So knowing this, we can apply the Pythagoras theorem to find the length of the diagonal. So we know that 8 squared plus 6 squared is equal to s squared. So 8 squared will give us 64 plus 6 squared will give us 36 is equal to s squared. 64 plus 36 will give us 100 is equal to s squared. So taking the root on both sides, we can say our x is equal to 10 centimeters. So the length of the diagonal is 10 centimeters. Very, very simple. You see how application questions on Pythagoras theorem are very simple. We take the next example. So this is our fifth example. Let's try our hands on it. You can pause the video and then you solve it. A square has a side 12 centimeters. What is the length of the diagonal? So a square is a plane figure with all the sides being equal. So if a square has a size of 12 centimeters, that means that all the sides are 12 centimeters. How long is the diagonal? You want to find the length of the diagonal. So the diagonal can be this side or from this very side. So let's choose this side. So the angle here is at right angle for a square. A square has all the angles at right angle. So this angle is at right angle, which is 90. This angle is at right angle, this angle is at right angle, and this angle is also at right angle. So knowing this, we can apply the Pythagoras theorem to find the length of the diagonal. So we know that s squared is equal to 12 squared plus 12 squared. So we have our s squared is equal to 12 squared will give us 144. 12 squared will give us 144. So we have our s squared is equal to 144 plus 144. We have 288. Then what we are going to do is we take the square root on both sides. So when we take the square root on both sides, we are going to get our x is equal to 16.97. What is the unit? Centimeters. So the length of the diagonal is 16.97 centimeters. Very, very simple. Now I'm going to give you a list of 12 questions and then you try your hands on them, okay? So these are a list of questions that I've prepared for you. I call it the tutorial set. So kindly pause the video, write the questions down, and then you try your hands on it. This brings us to the end of today's lesson. Kindly like, share, and subscribe to this very channel for more updates. See you next week. Bye bye.